Hello scholars, welcome back, welcome to the channel. What we're going to be doing right now is seeing the different methods by which we can find the LCM or the LCD, lowest common multiple, least common denominator. They mean the same thing. So what we're basically looking for is the smallest number that, given three other numbers, usually in the form of denominators when we're working fractions. That's usually how the whole issue of needing to find the LCM comes in. So we're adding fractions or subtracting fractions, and we want to find the lowest common multiple of two given denominators, or three or four, it doesn't matter how many. What we're really asking for is the smallest number that these factors have in common, the smallest number that they can all go into without leaving a remainder. Now there are several methods that we can use to find the LCM. The first method is to just look at the numbers and see if, from your knowledge of your times table, if you can just figure out from just using that knowledge which number, which is the smallest one, the lowest one that these numbers can divide into. Now, if you're very sharp on your timetables, many times you're able to just look at the numbers and be able to tell, right? But there are other ways, so I'm going to show you three other methods in this video, other than just looking and using your smarts, your wizzy, your skill, right, that you have honed from your knowledge of your times table. I'm teaching you three other methods. So, the first method, and this is actually the most tedious method, because depending on how big the numbers are, you can be listing for a long time, listing out the actual multiples. So this method is list out the multiples of the given numbers until you find the lowest common one, the smallest one that's common to all the numbers that you're dealing with, whether it's two numbers, three numbers, four numbers. So we're going to actually list out the multiples of 6, 3, and 9. And by multiples we mean basically the results of each number in the times table. That's really what we're doing, because a multiple is what you get by multiplying a number by another number. So 6 times 1 gives 6, 6 times 2 gives 12, 6 times 3 gives 18. 6, 12, and 18 are the first three multiples of 6. So we're basically saying then just list out the results of the timetable. So let's do that. So the first multiple of 6 is 6. 6, 1, 6. 6, 2 is 12. 6, 3 is 18. 6, 4 is 24. 6, 5 is 30. We can't stop there, because what we're going to do is to list them until we find the first one that all of them have. The first one that's common. So you don't need to list all the way. You can stop a little and list the others and see if you find one as yet, right? So for the 3, we have 3 1s 3, 3 2 6, 3 6s 18, 3 1s 3, 3 2s 6, 3 3s 9, 3 4s 12, 3 5s 15, 3 6s 18. I don't know how I reached 18 already. Alright, so let's stop there a little. The 9 now. 9 1s 9, 9 2s 18, 9 3s 27, 9 4s 36. Alright, so have you identified yet the smallest multiple that's common to them? So if we look, we see that 18 is common to all three numbers. 9 is common to 3 and 9, but it's not common to 6, right? Just as 6 is common to 6 and 3, but it's not common to 9. So we're given three numbers, so it has to be a multiple that's common to all three numbers. And that's 18. 18 is the smallest number that all three of them have. So the LCM of 6, 3, and 9 is 18. Using the method of listing out the multiples until we come to the first one that's common to all three. So let's do that for 4, 2, and 8. So remember, this is the first method. Other than just looking at the number, using your experience, your skills, your knowledge of your times table to just look. Some of us are able to do that for most, given most numbers. So now we're listing the multiples of 4. So 4 ones, 4, 4 twos, 8, 4 threes, 12, 4 fours, 16, 4 fives, 20. Alright, let's stop there for a while. We might have to list more, but we have to wait and see if we can find a common multiple or not. So for the 2, 2 ones, 2, 2 twos, 4, 2 threes, 6, 2 fours, 8, 2 fives, 10, 2 sixes, 12. Alright, I'm seeing two things that are common here. I'm seeing the 4 is common. Actually 3, I'm seeing the 8 is common. The 12 is common. So 4 is common, 8 is common. But we have to list the multiples for the 8 because all three of them, the multiple must be common to all three numbers. So we have 8 ones, 8. 8 2 16, 8 3 is 24, 8 4 is 32. Alright, so have we identified one as yet? Yes, we have. So if we look, we see the 8 is common. The 8 is the lowest common multiple. It's the first multiple that's common to all three. Alright, that's 8. The LCM of 4, 2, and 8 is 8. So that's a method you can use. It can get tedious, because sometimes you'll be listing for a long time, especially if you're given more than 3 numbers. You might be listing out the multiples for a long time until you actually find the lowest one that's common to all 3 numbers or all 4 numbers. So this one can be tedious, but it's pretty sure. If you keep listing them, you're going to find the lowest one eventually, right? Here's the other method. This method says, given 2 numbers or more, if the smaller one is a factor of the larger one, then the larger one is the LCM. So likewise, if you're given 3 numbers, if the 2 smaller ones can go into the bigger one, the bigger one is the biggest one is the LCM, right? So if we have 3 and 15, 3 can go into 15, 15 is the LCM, because 15 can go into itself. The number can go into itself. 4 and 12, 4 can go into 12, 12 can go into itself, 12 is the LCM. 6 and 18, 6 can go into 18, 18 can go into itself, 18 is the LCM. 2, 3, and 6. Remember, if the 2 small ones are factors of the biggest one is the LCM. 2 can go into 6, 3 can go into 6. And of course, 6 can go into itself. So 6 is the LCM. 4, 9, 36. 4 can go into 36. 9 can go into 36. 36 can go into itself. 36 is the LCM. So this is another method just by looking and knowing our times table. But the fact is, we're comparing the smaller ones and the bigger one and seeing if the smaller ones can actually go into the big one or the biggest one. If that is the case, then the biggest one is the LCM. You don't need to look any further, right? You don't need to look any further than what you're given. Once the small ones can go into the biggest one given, that's the LCM. Alright, the third method I'm going to teach you now to find the LCM is what I call the factor division method. I don't know if it goes by another name, that's what I call it. Because what we're doing here is we're dividing all the numbers given. We're going to be dividing them by common factors until we can't divide them anymore. So until we get a 1 in each column, and then we multiply the factors by each other, and that will give us the LCM. So let me show you what I mean. Sorry. So we set out a little table like this to put in our numbers, right? So we have 4, 6, 8. We're going to keep dividing them by any number that we can divide. You usually start with a small number like 2 or 3, right? And once you end up with a 1 in each column, that means that column is done. And you do the same until you end up with a 1 in each column, and then you multiply the factors. So let's start with 2. So 2 goes into 4 2 times, 2 goes into 6 3 times, 2 goes into 8 4 times. Let's try 2 again. 2 goes into itself 1 time. 2 can't go into 3, we're going to carry back down the 3. 2 goes into 4 2 times. Alright. Let's try 2 again. 2 can't go into 3. Keep carrying it down if it can't go into it. 2 goes into 2 once. And let's use 3 now. 3 goes into itself once. So now we multiply 2 times 2 times 2 times 3. So 2 2s 4, 4 2s 8, 8 3s 24. 24 is the LCM of 4, 6, and 8. See that? 24 is the smallest number that 4, 6, and 8 can divide into without leaving a remainder. So we just keep dividing it. Start with 2, and if 2 can't go into any of them, then go to 3, and so on. Until you get a 1 in each column. If it can't go into, if the number you're using can't go into any of them, write back that, and then you're going to work it with something, with another number until you get 1s in each column. So let's do these now, the same way. So we have 3, 8, and 12. Alright, so let's use 2. 2 can't go into 3, so we're going to put back the 3. 2 into 8 goes 4 times. 2 into 12 goes 6 times. Trying 2 again. Carry down the 3. 2 into 4 2 times. 2 into 6 3 times. Using 2 again, so keep carrying down these 3. 2 into 2 1. And finally, we're going to use 3, 3 into itself once, 3 into itself once. So we have 1 in all the columns. So it's 2 times 2, which is 4, times 2, which is 8, times 3. 2 2s 4, 4 2s 8, 8 3s. So this is also 24. Okay, so the LCM of 3, 8, and 12 is also 24, just as the LCM of 4, 6, and 8. So 24 is the smallest number that 3, 8, and 12 can all divide into without leaving a remainder. Let's try 5, 4, and 15. 4, 5, 15. Okay, so let's try 2. 2 into 4 goes 2 times. 2 can't go into 5 or 15. 2 into itself once. 2 can't go into 5 or 15. Let's try 5. 5 goes into 5 one time and into 15 3 times. And now we try 3. 3 into itself once. So we have a 1 in each column. We have a 1 in each column. So 2 times 2, that's 4. Times 5, that's 20. Times 3, that's 60. So the LCM of 5, 4, and 15 is 60. So 60 is the smallest number. As big as it seems, as big as 60 seems, it's the smallest number that 5, 4, and 15 can divide into without leaving a remainder. Alright, so let's do these 3 more. We have 2, 8, and 10. Let's see what's the smallest number that these can go into. We have 2, 8, 10. 2 goes into itself once, 2 into 8, 4, 2 into 10, 5. Let's try 2 again. 2 into 4, 2, 2 can't go into 5. 2 into itself once, 2 can't go into 5. And 5 into itself once. So we have 2 times 2, that's 4, times 2, that's 8, times 5, that's 40. So the LCM of 2, 8, and 10 is 40. 40 is the smallest number that 2, 8, and 10 can go into. So if you were listing out the 2 times table, the 8 times table, the 10 times table, you would not be able to circle anything until you get to 40. That's the lowest common multiple, or the least common denominator. Alright, 2 to go, 6, 7, and 10. 2 into 6, 3, 2 can't go into 7, 2 into 10, 5. Alright, these are all prime numbers, so we're really going to have to just divide them by themselves. 3 into 3, 1, and it can't go into those. 5 into itself once, and 7 into itself once. So 2 times 3, that's 6. 6 5 is 30. 30 times 7 is 210. Wow. 210. 210 is the smallest number that 6, 7, and 10 can divide into. See how, can you imagine if you were listing, if you were using this method? Can you imagine if you were using this method? You would have to list out the 6 times table until you get to 210. That would be a long list. That would be a long list. 6 goes into 210. 6 into 21, that's 3, that's 30 something. Right, you'd have to list 30 something numbers before you get to 210. And for the 7, you'd have to list 30 numbers before you get to 210, right? So that's what I'm saying. This method can be tedious by just listing them. And if you were just to look at them, many persons would not be able to come up with 210 to say, well, 6 can't go into 10, 7 can't go into 10, so this method wouldn't help us. This would be tedious. This one wouldn't really help us because they can't go into the 10. So this method is very convenient. It's shorter in many cases. In most cases, I would say this is the shortest method. If you're not able to look at them and know one can go into the other, right? If they can go into the other, this is a quick method, right? But if you're not able to tell by looking, it's best if you just go through this method. You'll definitely end up with the LCM. Alright, so let's do the last one. So we have 3, 9, and 15. So They're all odd numbers, so we can't start with 2. So we start with 3. 3 into itself once, 3 into 9, 3, 3 into 15, 5. 3 into itself once, 3 can't go into 5, and 5 into itself once. So we have 1s in each column. 3 times 3, that's 9. And 9 times 5 would be 45. So 45 is the smallest number that 3, 9, and 15 can divide into. So if you were adding fractions and one of them had 3 in the denominator, one of them had 9, one of them had 15, 45 would be what you put under the line if you were adding or subtracting fractions. That's how the LCM comes in handy, right? Finding the least common multiple, least common denominator. So these are 3 methods that you can use. But let me tell you, the sharper you get with your times tables, practice your times tables, then the better you will get at. Sometimes you can just look at the numbers and immediately know what the LCM is, right? But these are sure ways of finding it. If you just can't figure it out, just go step by step, do the method, and you will get to the LCM. Alright, so if you have benefited from this video, just drop me a line in the comments to say thank you, miss. And don't forget to share the videos. As soon as you watch one of these videos, share it so other students can benefit from it. And if you don't see the video you're looking for, just let me know which video you want me to do, which topic you want me to do a video on, right? Please subscribe. If you haven't subscribed as yet, subscribe so you can get notifications. Click the bell so you'll get notifications to know as soon as a new video drops, because you want to stay on top of things. As a scholar of mathematics, you want to stay on top of things. Alright, so I'll see you in the next video.